Hello, boys and girls. Welcome to Science and Daily Life. I am Sir Zamin.
And I am Miss Freeman.
I do hope you're ready for us to go on yet another exciting journey in science. In our previous lesson, we looked at electricity, where we looked at the components of an electrical circuit. Today, we will be looking at matter.
Now, boys and girls, our objectives for today is to differentiate among matter, mass, and weight. We're also going to list tools used to observe matter. And finally, we're going to identify the physical properties of matter.
Okay, boys and girls, let us look at some key terms when discussing matter. Firstly, observation. An observation is something that you experience with your five senses. Inference. An inference is a decision you make based on your observations and questions. Hypothesis. A hypothesis is a prediction that you arrive at after making your observations. So what is matter?
Now, matter is anything that has mass and occupies or takes up space. For example, boys and girls, can you list some things that has mass and occupies space around you? Let's take a look around us. We have some table, chairs, maybe a book is on your desk, the book you're writing with. They all have mass and they occupy some amount of space.
So students, Miss has been speaking about mass. So what really is mass? Mass is the amount of matter or things in an object. It is measured in grams or kilograms. For example, a paperclip has a mass about 1 gram. A liter of milk has a mass about 1 kilogram. You can measure mass with a balance.
For example, boys and girls, you can see an image here of a pan balance. Let us talk a little bit about weight. What is weight? Weight is a measurement of the pull of gravity on an object's mass. Because of gravity, weight is not the same everywhere in the universe. On the moon, you would weigh less than that of Earth. Now, let us talk a little bit. We're saying mass, we're saying weight. What do we really mean? Now, mass, as Sir would have said, is that amount of the substance, whereas weight is how gravity acts on that amount of substance.
And boys and girls, we would hear individuals using the terms mass and weight interchangeably, thinking they mean the same thing, but I assure you, they do not. Because as I mentioned, mass is measured in kilograms, or sometimes we can express it in grams. For example, I'm sure you guys would have walked down Robb Street or Regent Street. Before you reach the bus park, you may hear some people saying, come check your body weight, check your body weight. But tell me, when you jump on that scale and you look down, the graduation is in kilograms. So you're not checking your weight there, you are checking your mass. It is after you multiply your mass using gravity, then you convert that to weight.
Very good. Now we're talking, boys and girls, about gravity. What is gravity? Now, gravity is the force of attraction between two objects. All objects with mass have gravity. Gravity acts like a magic, pulling objects together. Now we're standing here. And you're standing there, boys and girls, you have a mass. Gravity is allowing you to stay grounded, or where you are in the position that you are. Now, let us talk a little bit about the mass of an object and its parts.
Take, for example, boys and girls, you have 5 wooden blocks that are all the same. They have the same size, they have the same mass. You can therefore measure one of those blocks using a balance and say, for example, it's 25 grams. You can therefore now say if you stock all 5 blocks together, the total mass will be 125 grams by simply taking 25 times those 5.
So what we're saying, boys and girls, is that the mass of an object is equal to the total mass of its parts. Simply, we have an entire object, like Sir would have said, we have 5 blocks. That entire 5, or those 5 blocks, can combine to give us one object. The 5 separate blocks will have their own individual mass attached. But when we combine them, we would have the total of that. So therefore, boys and girls, the mass of an object is equal to the total mass of its parts.
And miss, for example, when we go and take our weight, you see I'm using the wrong term again, we take our mass, not our weight. When we go to check our mass at a doctor, what they normally ask us to take off our footwear. Why is that so? Because of this same very concept that Miss is explaining. Because your shoe or your footwear would add to your total body mass. So that is why we remove our shoe to get your body's mass.
Now, how many of you would have played with puzzles before? I am sure we have had many puzzles, small ones, big ones, having multiple parts. The same concept we're getting here is that even though they have individual parts, when put together, they will create something big and large together. There is a mass attached to that together. And there's also a mass attached to that of the individual parts. Do you think if we put the individual parts together without creating that puzzle, would they have the same mass as when we put them together, creating the puzzle? Yes, they would, because adding them individually will give us what the total is.
So, Ms. Riemann, we're therefore also saying that when we refer to mass and weight, what I weigh here on Earth, I'll weigh different if I go to the moon.
Yes, you would.
I'll be lighter, right? So it's to show you that weight is dependent upon mass and the gravity. Now mass, boys and girls, it is never lost. It just changes its state. For example, if you're to leave a bowl out with water in the hot sun, after a while, the water will evaporate and the mass will decrease of that bowl. It is equal to the mass of water that has been evaporated into the air.
Very good. Now, we're talking so much about matter. Let us talk a little bit of when we're observing matter. What are some tools we may use to do those observations? Now, objects and materials are made up of smaller parts that can be too small to see with our eyes or your eyes. You can use a magnifying glass, or you can just magnify what it is to make them appear larger than they actually are. So boys and girls, to see some matters, we basically can use a magnifying glass.
In addition, we can also use a hand lens. A hand lens is one tool that makes small objects appear larger. You can use this to see the parts of small objects. For example, to see the tiny hairs that covers a bee's back, or even veins of a leaf.
Now, boys and girls, take a look at an image of a hand lens. Now, another tool, boys and girls, we can use is a microscope. What is a microscope? A microscope is a tool that makes tiny objects appear much, much larger. Boys and girls, do take a look at a diagram of a microscope. Now, let us talk a little bit about properties, the physical properties of matter.
So, boys and girls, a physical property can be observed using tools. It is used to describe, compare, and group kinds of matter.
Now, boys and girls, what do you think we can use to compare, describe, and talk about different things or group things of matter? We use our 5 senses. Can you name our 5 senses? Can you recall our 5 senses? We have our sense of sight, our sense of hearing, our sense of taste, our sense of touch, and our sense of smell. Now, in order to use our senses, these are a few things in which we can observe. Firstly, we can look at the color of an object. We can say, you know what? We can observe by looking at the substance, seeing what color they may have, and so on. For example, sulfur is yellow, graphite is gray, and salt is white.
You may also use your tongue for tasting. However, I'm cautioning you, we do not taste anything in the laboratory, right? I'm talking around in our home, you can taste if something is sweet or salty. if mommy put a little too much of salt in the food or not. And texture. What do we use for texture? Our hands. The way a surface feels. You can touch to observe texture. For example, it may be smooth, waxy, soft, powdery, greasy, or grainy.
That's correct. We can also talk about volume. What is volume? Volume is the amount of space that something takes up. Volume is measured in two different ways. For example, there is the formula length times width times height. And there is also water displacement method. For example, a tennis ball takes up more volume than that of a marble. Next, we also have density. What is density? We can observe these things from matter. Now, density is where an object mass is divided by its volume. It tells us how tightly packed particles are in that of an object. If an object floats, it is less dense than the liquid. If an object sinks, it is more dense than the liquid. For example, a cube of sugar has a lower density than a cube of iron. That is the same size. We have two cubes, they're the same sizes. Iron and we have sugar. One of them will sink and one of them may float. What will it show? Basically, it will show that one has a lower density than the other.
So therefore, boys and girls, we can conclude based on what Miss is saying that when we compare objects of the same volume but different masses, we are actually talking about their densities. So one can be denser than the other. We will now move into looking at an activity to show that some objects would sink while others will float.
Now, boys and girls, you can see in front of us here, we have 4 beakers of water. Next to each beaker, there's an item which we will test to say, will it sink or float? First, we have a ball of Play-Doh. Secondly, we have a Christmas decoration. Thirdly, we have a piece of plastic. And lastly, we have a paper clip. Do you think these items will sink or float? Let us go.
Yeah, let's get right into it. So the first item, it's a Play-Doh rolled into a ball. So what do you think? When I place it in this beaker of water, will it sink or will it float? Bam, it sank. So the piece of Play-Doh rolled into a ball, sink.
Good. Let us take a look at another item that we have on our list. We have the Christmas decoration. Do you think it will sink or it will float? Let us see. So we have our Christmas decoration. And we can see that it floats.
Definitely floats.
All right, so we have another item here as well. We have our piece of plastic. What do you think, boys and girls? Will it sink or will it float? Let us try that. And it sank. All right, so the next item that we have here is a paper clip. What do you think will happen? Will it sink or will it float?
Let's go right into it.
And it sank as well. So, boys and girls, we're looking at sinking and floating of an object. But what are we really talking about? Here it comes back to the density of an object. If an object floats, it is less dense than the liquid. If the object sinks, it is more dense than that of the liquid. So these items, you have 2 of them that sank and there are 2 of them that float. We can identify which one is less dense than the liquid or which one is more dense than the liquid.
Do have fun with this activity at home. Go get a bowl of water, get some objects around the house and see if it will sink or float. So you will be able to use a better term. Instead of saying, hey, it sank, say, hey, this object is more dense than water, hence it sink. So now you have a reason, an explanation behind floating and sinking.
And you know, little boys and girls, you are our little scientists. So you go and explore and make your own observation of matter. Now, today, boys and girls, we discussed the difference between matter and mass, and we also look at mass and weight. We also talked about some tools used to observe matter, and we identified the physical properties of matter. Until next time, I am Miss Riemann.
I am Sir Zamin.
Bye-bye.